Okay. So yesterday we did a lot. Um, we now know how to configure the Ethernet adapter here and the NIC bonding. Okay, so if one device goes down, then the other one will stay on when it considers the network. Okay, all right, so this looks good to me. So we went over this here. Okay, I'll start a little bit about network, how the network is. In no way means this is a network class. It's just a little brief description how the network works and all that, okay? So So we'll talk about network a little bit here. So when you type in here, what is a network? Okay, so this is the just simple definition. We'll keep it here. Okay. And servers, computer. No, I don't like this. So we'll see here a computer, a network is a collection of computers servers, network devices, and peripherals. Okay, let me make sure I started the recording here. Yeah, the recording is on. Okay, and or any other devices here. So servers, computers, peripherals, or any other devices connected to one another to allow the sharing of data. Okay, and the example is internet. Okay, so let's see here. For a basic network, you need about four things which is going on when you need a basic network requirements. Okay, basic requirements. Okay, so what you need is a NIC card, network interface card, and you need a media, and you need a topology, protocol, and the IP address. Okay, these are the ones we're gonna concentrate on. So NIC card. So the NIC card is nothing but a network interface card. So the basic thing about NIC card is it has a, why can't I paste here? Oh, come on. Copy image. All right, you don't want to cooperate. Should work now. Okay, so the NIC card, this is a hardware address. Okay, so it has a hardware or MAC address. We talked about this yesterday. So the NIC card has a hardware or a MAC address. Media access control address. Okay, and then one of the example would be okay, So this is the example for the media access control. MAC address. Okay, so when you run this through, it will tell you who the manufacturer is and all that good information here, okay? And then the IP address, it controls the IP address. Okay, and so this is the example of a IP address. So this is a example of IP version 4 address. It's called IPv4. Okay, this is the one we are most familiar with. And there is another IP address called IP version 6. IP version 6, right? So let's take a look here if we have one here. So in here, this is the IP version 6 address here, okay? We're not going to deal with that a lot here. So, but this is just an example here. So the future is going towards this IP address here, okay? So most of the desktop computers or laptop, this is using this IP address, and the devices, the small devices like iPhone or smartphones or any other, it's using this IP address here, okay? Your little TV adapter, which is like a Roku or what else we have there? Or like those one of those. Is it like Chromecast or something? Yeah, those things. They're using IPv6. Okay, so on your phone, if you do what is my IP and disconnect Wi-Fi, and when you do what is my IP, it will show you your IP address there. If you go to a website called what is my IP, it will show you this IPv6 version. More than likely, that's what it's going to show you. Because why is it showing you that? Because we are running out of the standard IP version 4 IP addresses. I'll show you why. Okay, make my IP. Well, anyway, I'll talk to you about that a little bit more. Why is it? Why are we running out of it? Okay, so this is NIC card. Oh, come on. Below here. Can you guys hear me okay, or is it I'm breaking in and out?
It's fine for me.
It's all right.
Okay, good.
Fine.
I was having a network problem this week. Okay, good. And then the next thing we're going to worry about is media. We'll take a look what media is. Media. Oh, God. Okay, so what is media? Media is simple things like cables, RJ45, Wi-Fi. These are just the mediums here, okay? Hotspot. Okay, so you get the idea. These are just the media which is helping it for the data to flow through from one device to another device. Okay. All right. So, but after that, we'll focus on topology here. Okay. Topology. I normally don't like this being highlighted. Yeah. Okay. So let's work on the topology here. Okay. So there are several kinds of topology. Um, let's see here. I'm gonna insert about 4 boxes. The very first one is a ring topology. Okay, and what does it look like? Ring topology is okay, so this is what the ring topology is. It's just all the systems sitting up in a circle. Okay, so we are not using this a lot. Only reason oh, come on. So this is ring topology. And the next one we have is bus. Okay, and it sounds just like a bus. What it is it's in the row. I'm going to type bus here. Okay, so I'm just explaining you this. It may be just too easy here, but this is not a focus. But what comes after this, it will make you understand why am I just doing this simple, silly information I'm throwing at you. Okay, and then there was one other one called star topology. Okay, so this is a star topology. The connection is there. So you could see this is how the technology was developing here. First it was ring, all the computers connected to each other. If one computer breaks down, then it may not pass on. The entire network breaks down here from this point to this point. It may not communicate, or it may communicate from here to here, but it won't communicate or make a circle around here again. Okay. Similar thing with the bus topology is if one of this there was a communication here, this may not be able to communicate with other computers. Okay, so star topology kind of resolve that issue. So it's just like a star here. If one computer goes down, no problem. And then now the one we are using is mesh. Okay, so you take a look at the picture here, and it's just like a mesh here. If one of them goes down, no problem. Everything else will still be there. Okay, and this is the mesh. Okay, and the last one is a tree. Tree topology, and this is being used everywhere now. So let me see a good picture here. Tree topology. I want to see some routers in here.
Top
Okay,
right. If you go to the top, the right corner, keep going. Right there.
this one.
Underneath.
Oh, this one. Tree. This one here, right? Yeah. No, these are just the switches. This is a little blurry. I kind of like that one. Let's look at this one here. Mesh. Oh, God. Okay. Okay, and merge. Okay, so I found this picture. So now what is going on here is we have a massive network here. So this is how the modern networks are working. They have this massive networks here, and each time you add a router, it becomes a subnet. Okay, so I'll explain you what subnet is in a minute here. So you have a network, you have a network here, and each router you add, it becomes a subnet. Okay, and the maximum you could have here okay, so I'm gonna say these are the routers here, right? This is the router here, and it's gonna go like that, and the maximum each router produces is about 256 devices. Okay, your home router is capable of handling 256 devices, including phones, your tablets, computers. It's not going to do anything more than that. And where is this coming from? This is coming from 2 to the power of 8 equals, if you do 2 times 2 times 2 times 2 times 2 times, how many you got? 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this is how this networking works on based on 256 devices here. So the maximum each router, then what happens is, then you add another router in one of this port here, then it becomes another subnet here. Okay, so now this router is support 256 including this router, and this router will give out another 256 handle another 256 devices. Okay, and it's 2 to the power of 8 equals 2 times 2 times 2 times 2. Okay, 4, 5, 6, 7, 8. Okay, so let's make sure I'm doing it right here. Let me bring out a calculator. So I'm doing 2 to the power of 8 times. It's not 2 times. It's not 2 times 8. 2 to the power of how do I use this? 2, right? Okay, 2 times 2 times 2 times 2 times. Keep multiplying 2 times. Times 256. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. When you multiply 2 times itself for 8, it lands at the 256. Okay, we'll talk about why is it stopping at 256 a little later here. Okay, now let's concentrate on next item in here, which is a protocol here. Okay, so we'll work on protocol. And okay, so what is protocol? Let's see what protocol means is. A network protocol establishes a set of rules that are determined how data is transmitted. Okay, yeah, I like this. Or just put down protocol. Okay, let me put down a simple here. Um, in a computer world, protocol is set of rules, okay, or procedures for transmitting data between electronic devices such as computers. Okay, and before that, there is something called a network OSI model, OSI layer. Okay, so this is defined by open standard interconnection. OSI is, what is OSI? Open standard interconnection layer. And there are 7 layers here. The first one is the physical layer. Okay, which is the hardware. Okay, the computers and all those things are physical layer, which you could touch and feel is a physical layer. Okay, and the data layer is where the data is generated. Data is generated. Okay, and the network layer is a network, network, working network. And these are switches, routers, etc. Okay, even though those are hardware, so the hardware, this hardware falls into physical and network layer here. Okay, so it's possible that one item could fall into multiple layers. And transport layer, okay, so this is a layer where the um, communication is done using several methods. Yeah, you got a question? Okay, and then the session layer. What is a session layer? Session layer establishes the connection between two devices. Session is a connection established two devices. Okay, and the presentation layer. Presentation layer is uh, data is presented to application, and the application layer is, can you go on mute please, is the application. So example is MS Word. Example is Microsoft Word. Okay, this is the application layer. So let me see here. Physical data network transport in session layer, presentation layer, application layer. Okay. Okay. Yeah, these are the layers here. If you are a network student, you have to worry about all this here. But we are not teaching a network class here, so I'm just showing you what you should know here. Okay, so this is the most you should just worry about here. But we're gonna go into a little bit of protocols here, how the protocols is working. Okay, so the two protocols we have to worry about is the TCP and UDP here. Okay, so I'll tell you what protocol is. So the protocol, so now I'm actually talking about protocol here, because this is just extra stuff you need to know. So we are worried about the TCP protocol. So it's called a TCP protocol. So it stands for Transfer Control Protocol. Okay. So what is this here? It's called TCP. Uh, it's a connection protocol. Okay, it establishes a connection. It's a connection protocol. Okay, and when you establish the protocol, it's using these layers here. It's using the data layer and network layer. Okay, and it uses the transport layer and application layer. So DNTA, short for DNTA. So you might be quizzed in the interview. It says what is the which layer the TCP protocol runs on. You just have to say data, network, transport, and application. Okay, and right here I'm gonna clear this, and I'm gonna say PS-EF, and then we'll go through this again a little later here. Okay, what I'm doing here, but for now, uh, 21. So in here, you see port 21 is okay. Yeah. Uh, which netstat? Okay, so what I'm going to do is I'm going to download a utility that will show us the uh, protocols that which are running right now. Okay, so let me see here. So when we are connecting from PuTTY to this place here, we are using a protocol. Things are just not going to connect just because you're using it. So it is using, it's connecting to the port 22. I'll come back to that a little later. And it's using a protocol. Okay, protocol is nothing but a methodology how the connection is being established. So yum install net tools -y.
Hey, Mr. Zafar, should we be doing this as well?
Uh, Not necessarily. You know what? Yeah, go ahead and do it.
Okay.
Because the system we installed here, we installed the bare bone system. We didn't install too much because I
Okay.
want to carry this over and I want to show you how you do the updates and all that.
All right. Can you tell us what to write one more time, please?
Yeah, hold on. Let me see if I don't. Oh God, I don't have a good. I don't have an internet connection here. What is going on? Oh, so we yesterday we disconnected one here. So I'm gonna have to shut down first. Yesterday I was performing the demonstration, right, on how to do the um, network. What was it yesterday? I was showing you network bonding. So I disconnected one Ethernet adapter here yesterday. So I'm gonna put this back, and you have this enable NAT. It will bring you the internet connection. Okay. It's not. Let me see if I could do this here. Yum install nettools -y.
Mrs. Zafar, should we just wait after we get a complete?
Yeah, were you able to install on yours?
Yeah, it says everything. Dependency resolved, installed, complete, and it's
Yeah.
on root local.
Okay.
Just wait.
Yeah, give me a moment here. Yeah.
Say, were you able to ping Google? No, I haven't tried that yet. Oh, okay. Mrs. Zafar, I'm pinging Google. Mine's running.
You are having problem too?
No, mine is running. It's fine.
Yeah. Okay. Yeah. Yeah. I think I have a
Yeah,
problem.
mine's running too, Austin. Yeah. It's running right now, Austin. All right.
Give me one moment here. Okay, you guys hear me? Hello?
Yes, yeah.
Okay, sorry about that. Yeah, okay, so let me go ahead and install the net tools. I don't know. I bought the brand new router here and it's acting up, so I'll fix it before next week. Okay, so let me clear this. So if you want to see netstat, I push netstat enter and hit enter, and in here you see some says protocol is using TCP, okay, and let me clear this. Netstat hyphen ANP. Oh, it's getting too many.
And Mr. Zafar, quick question.
Yeah,
I tried the ping google.com on here, and the list keeps going down. It's not stopping. Is there any
yeah,
way to stop it?
yeah. Do Control C.
Okay, thank you.
Yeah. So grep 22. Okay, so let me clear this. If you type netstat hyphen ANP, then grep hyphen W22. So we'll worry about this later here. The only thing I want to demonstrate here is right now we are connecting using port 22, right? When we connect using PuTTY, we put in the port 22 and it's using SSH and we put in the IP address here, right? But the protocol which is using to connect between this PuTTY and in here, this box, virtual box, it's using the protocol which is TCP, Transfer Control Protocol. Okay, and it's working on port 22. So that is something else I'm going to explain that. The only thing I want to show you here is TCP. Okay, so it will tell you what protocol it's using here. So we'll see how the TCP control protocol works. So there are a lot of protocols out there, but you are worried about in the Linux environment, you're worried about the TCP and UDP. So we'll just worry about TCP for now, okay? So I'll show you what TCP means. And it is a connection oriented protocol. Okay, and then TCP makes three-way handshake. Three-way handshake connection. Okay, I'll explain you. Let me go get a picture first. What does this means? Okay, so let's see here. I type TCP protocol. And let me go into the images here. Okay, this is a good picture here. So this is a TCP protocol connection here. So right now, this is the connection between our putty and this virtual box here, okay? So I'll explain you how the putty works. So this is a TCP. TCP makes three-way handshake connection. Okay, so let's see here, how is this working here? So how is the connection established? Establishing connection. So when the connection is initiated, what it does is the server on the left sends a signal to the server which is making connection to. It's gonna send a packet that says sync. It says a synchronization packet here. But before that, let me make some edits here. Client for this, don't worry about this here at the moment. Okay, TCP client and TCP server. Okay, that would be. Let me just make it edit here. We don't have to be a TCP. Let's say here. I'm gonna say. I'm gonna say server A. Server A. Okay, and here I'm gonna say server B. Server A and server B. So how is the connection established here from server A? What server A does is server A to B. A to B. So synchronization packet is sent. Okay, a packet is sent from server A to server B. Okay, and then what happens is server B to A, what it does is it also sends its own synchronization. Packet, and also it sends the acknowledgement packet that it received the first response. what is the acknowledgement packet? That it received the synchronization packet from A first, A to B, and B to A. Okay, now it's going to play the game now. Then B to A, I'm sorry, A to B. Then it says, it then sends another acknowledgement packet. So server B in one instant is sending both at the same time. Server A is sending one, then acknowledging it after you receive the. It's just a communication here, right? I mean, is sent here. Okay, and now the connection is established. All this is happening in the fraction of a second. Okay, so for the short, it's what you do is you say sync ACK ACK. This is how, if you get a question in the interview, it says how is the connection established, TCP connection established. You just say sync ACK. That's it, nothing more. So it's syncing and it's acknowledging and it's syncing and it's doing the sync and acknowledgement at the same time, and then it's acknowledging again. Okay, so this is called a connection package here. I'm sorry, TCP acknowledgement here, establishing a connection. Okay, so yes. Okay, so connection is established here. Okay, now what we're gonna learn about is how to terminate the connection. TCP termination. So when we are terminating from this here, so this is what you see here. So let me bring up my Google here again. TCP protocol. Okay, so what will happen here is now I have to edit here. can't seem to get this here. Let me try one last time. Same thing. Okay, good. Now, what will happen is it will. How is the connection terminated? So it will send finish, FIN. Okay, that means I'm done here. So let me change the font here. Come on. I'm so sorry about all this. So it sends a message that says I'm finished. Okay, and then the server B, what it does is it will acknowledge it. Okay, it will say ACK. It says finish. I'm finished too. That means I'm done. Okay, and then ACK, ACK. A stands for acknowledgement. So how is the connection terminated? So what is going to happen is A to B is going to say I'm finished. Okay, so it says complete connection. Okay, and then B to A, it says B to A, it says I'm acknowledging, and then finish, acknowledge and finish. Okay, and then again A to B, it says I'm acknowledging you. Acknowledge finish signal. So over here, then B to A again, finish signal. Okay, let me just do this here. So it looks a little complicated here, but it's not. So the final word is you type FINAC, FINAC, then ACK. Okay, so all right, so I'm gonna. So it says finish signal, then finish acknowledgement, and finish act. Okay, this is how it works here. So when connection is terminated, you use finish, and when the connection is established, you use sync. Okay, so I'm sure you guys are confused here a little bit, but don't worry too much about it. You just need to know how the connection is established. That's all it is. But I thought if you have this visual here, that will help you understand this. Here, okay. Now, so the connections are there. So let's see here. So I'm going to make a note here that our SSH is using the TCP connection. Okay. And how do you check the TCP connection here is you run this command here and you'll see the TCP connection. Okay, now there is another type of protocol. It's called UDP. This is a TCP control protocol. And there is one more protocol we need to worry about is UDP. UDP. Okay, so this stands for, what does UDP stands for? Yeah, you have a, you know what UDP is? Go ahead. UDP.
No.
Yeah. So UDP is, this is a universal, no, not universal, user datagram protocol. User datagram protocol here. We'll come back to this here. So user datagram protocol. So this is a connectionless protocol here. So it's like a broadcast. Okay, and so it just sends the data over the network. Okay, and it doesn't care. There is no confirmation if the data is received or not.
Like streaming?
Very good. Streaming. Or the radio. You know, the car radio.
Yeah.
Wherever the radio station is broadcasting, they don't care. They just broadcast it. If you get it or not on your side, it's your problem. They just make sure their broadcast is up and running. Okay, so it's called broadcast. Received by the sender. So there are two kinds in here. Two types of. Let me see here. So two types of UDP. Okay, and one is a broadcast, that is the official term. Okay, one is called broadcast and multicast. Okay, so what is a broadcast is, let's
One
see.
way traffic.
Yeah, go ahead. What?
One way, I say.
Yeah, very good.
One to many relation.
Yeah, so I have this good picture here. So it is sending the message to all of them, but it doesn't care if the all of them received or not. It's called broadcast, like a TV radio, like a radio station. Oh God, I can't copy and paste here today. So this is a visual for a broadcast, okay? And then the multicast, UDP multicast. So multicast is you have to be part of a group. If you're part of a group, then you will get the message. If you're not part of a group, then you won't get it. For example, I think multicast you could put it on like an XM radio. Okay, so if you're paying for the subscription and you're on a group, you will get the signal, or else you won't get it. Okay, without confirmation, and here signal is sent only to the group. Like if you're sending an email, you have a group, right? You could send everybody an email in your book list, your contact list. Like if you go on a work, you have like you could send it to everybody, all, or you could just send it in a group. I'm sure you guys know the group emails. So if you just send it to the group, only that group, only those people in that group gets it, but it doesn't care if they get it or not. There is no confirmation. It just sends it. Signal is sent only to the uh, hosts in the group. GROUP, without confirmation. Okay, yeah, that's about it. Okay, and then I'm gonna make a note here. So I'm gonna make a table here, the difference between the TCP and UDP. Okay. Okay, so the TCP on one side and UDP on other side. So first point is TCP is a connection oriented, a connection oriented communication. Okay, whereas B, UDP is UDP is connectionless. It doesn't care if it establishes a connection or not. Okay, and let me get rid of this here. Just okay, and one other thing is TCP is reliable. Okay, TCP is reliable. Why is it reliable? Because it's making and confirming the connection here, and UDP is unreliable. And UDP is fast. Why is it fast? Because it doesn't have to be waiting for the connection information and all that. It's not going back and forth before it's uh, establishing a connection. And TCP is slow. TCP, I mean, these are all fast. But if you compare between both of you, UDP is much faster. An example for TCP is HTTP. Okay, you've seen HTTP, right? FTP, we're going to learn this. SMTP, these are protocols. And TCP itself. Okay, and then for the UDP, the service is going to use is DNS, DHCP, and broadcast. Okay, so this is what we have here. So in all today's class, you just have to worry about this much information here. You're not too much. Okay, and let me take a look here. I think I covered too much already. Okay, now the next thing I'm going to cover is I'm going to talk about the IP address. We're going to break down how the IP address is working. Okay, so you don't need to worry about too much about IP address either, but I thought it would be good idea you guys would know a little bit about more about just looking at the number rather than uh, IP address. An internet IP address lookup is determined by yeah, this is good example here. So it serves like two purposes here. So it is like a host or a network interface identification and location addressing. So it is doing a lot of things here. So we're gonna break down the IP address of this system here, and then we'll show you how it's actually working. So the IP address we have is 192.168.1.250. Okay, well, we're gonna study this IP address here. Okay, and in computer world, so how is the computer communicating? If you send a message to somebody, it goes through all the things here, right? But it converts itself into the binary code. Computers works on binary. That means it can recognize only two digits.
0 and 1.
Yeah, very good. Very good. It can recognize only two digits. Okay, and it's called base 2. Okay, and which is base 2 is 0,
1.
which is 0 here, and 1, which is number 1 here. Okay, and 0 stands for if it's a 0, well, that means it's off, and 1 means it's on. Okay, so let's grab a picture of binary. Okay, so I don't care who's writing what. In the end, this is what the computer understands here. Okay, because it was established that all these numbers and codes, letters and everything, it changes itself into binary, zeros and one. This is what the computer recognizes. This is how it saves it on the disk. Okay, so I'm gonna grab this picture here, copy, and I'm gonna paste it right here. Oh, it worked this time here. So this is what the computer understands. This is the computer language. So we don't have to worry about this here because we have the compilers who is doing it. People who have established this already, and the systems are developed there that is writing in binary codes. I suppose some developers are people who need to know binary codes. They are using this too, but don't ask me to explain too much about it because I can't. I don't know how the binary works too much. But I could explain you a little bit here that how the IP address is working, and then we'll move forward based on that. Okay. So the IP address works on uh, is a base 32. IP address is a 32 bit, is based on 32 bits. That means 8 octets. 8 octets each. Okay, and information is written in binary. Okay, so let's see here. So the system starts, the decimal system starts from, where does the decimal system starts with? What is the first number in the numbers?
0.
0, very good. The system starts with 0, it doesn't start with 1. So we have 0, 1, 2, 3, 4, 5, 6, 7. So 0 to 7, how many numbers? 8.
8.
8, 7, 6, 5, 4, 3, 2, 1. Okay? And how does the 0, 0, 1 happens here? How does the 1 happens here is, so we are using this as an 32 bit. Okay, so 2, 4. So now here's another interesting thing is so we have a 0, 1, 2, 3, 4 here. Okay, and now the very first one is we're going to use 2 to the power of 0. In 2 to the power of 0 is 1. Okay, 2 to the power of 0 is 1, and then everything is based on 2 base, right? Now why is 2? 1 and 2, this is 2. It starts with 0, but this is 1 and 2, this is base 2. Okay, then 2 to the power of 2, I'm sorry, 2 to the power of 1. 2 to the power of 1 is how much? 2. Okay, now 2 to the power of 2 is how much now? Now it's doubling now. Now it's 4. Now 2 to the power of, God. 2 to the power of, what do we have now? 3, right? 2 times 2 times 2 is, how much we have now is 8. 2 to the power of 4 is 16, 32. It's doubling itself here. 2 to the power of 2 to the power of, now we are at 5. Okay, uh, 2 to the power of 6 is how much? 64.
64.
Yeah, and this is 128. Okay, 2 to the power of 7. Okay, it looks 7 here, but it's actually 8. Okay, so remember that. Now let's take our IP address here and we're going to decode it, what is actually it means here. Okay, so let's go here. So what we're going to do is we're going to take 192. Okay, 192, and then we're going to decode this part here first. Okay, so we're going to use the formula we have here up here. So let me copy this. Okay, I'm going to get rid of this part here. Okay, now what we're going to do is we're going to do math here. Okay, so 192, right? We take 192 and we're going to subtract 128. 128. And how much is left here? How much is left? 128, 192 minus 28 is how much? 64 is left, I think. So 192 minus 128, 64 is left here. Okay, 64 is left. We type 64 minus 64, and then nothing is left here, right? So nothing is left, 0 is left. So we're not going to use these boxes here because we have nothing to subtract from. All this is going to be 0, 0, 0, 0. Okay. Now, since we used the first box here, we're going to put 1 here. We use the second one also. We put 1 here. Everything else zeros here. Okay, good. Now let's grab 168. And what we're going to do is we're going to do the math here. Again, copy this same thing here. And I'm going to undo this here. We're going to copy. I'm going to copy this part here, 3. Okay, I'm going to copy this here. I'm going to put it here. We are decoding. What we are decoding is we are decoding the 168 here. So what do we do? 168 minus 128. So how much is left here is, so how much? 0, 0. Okay, so the 40 is left. 40 is left. Okay, but we cannot subtract 64 out of 40, so it's going to get passed down to here. So we do 40 minus 32. So we are able to do that here. How much is left? 40 minus 32 is 8. 8 is left here. Okay, and no, actually, yeah. $40 minus 32 is, how much is left? 8 is left, right? Yeah, but we are unable to subtract 16 out of 8. So we're going to pass 8 here. It comes on to this place, and 8 minus 8 is 0. So 0 is left here, and since nothing is passing down, it's all 0. So first, since we used the first octet here, it's going to stand 1. We didn't use this one here, so this is going to be 0. We use this one, 1. We didn't use this. And then this is going to be 1, and everything else is going to be 0. Okay, so now so 192 has become, what is 192? 110, followed by all these zeros here. We are putting this up here there. 1, 2, 3, 4, 5, 6. Very good. 6 zeros. 2, 3, 4, 5, 6. Okay. Now what has 168 has become? 1, 0, 1, 0, 1, followed by 3 zeros. Okay. Now let's play the game for 1 also. 1. So what we're gonna do is
128 minus 1.
yeah, so 1 is there, right? We are unable to subtract 128 out of 1, so it's going to be 0. Okay, it's going to be 0 because we know this is 1, right? So it's all this is going to be 0. And then we do 1 minus 1. Now it's finally to 0 here. So in the tab here, we're going to use 0, 0, 0, 0, 0, 0, 0, then 1. So actually 1, computer, this is how it writes here. 1, 2, 3, 4, 5, 6,
7
7.
zeros.
7 zeros followed by 1. So if you save 1 on the computer, it's save as this. Okay, this is how it is. Okay, and then what is the last number is 250. 250. Okay, let's see how is this working here. We should be able to finish this on time. So we have 250 minus 128. Okay, so 250 minus 128. So I'm gonna bring my calculator here. 250 minus 128 is 122 is left. 122 minus 64. So I'm gonna subtract
62.
64. How much is it? Oh God, 68, 58. 58, right? Yeah. We're down to 58 minus 32. 58 minus 32 is how much? 26. Okay, 26 minus 16 is 10. Minus 8 is 2. Okay, we can do that. So now 2 minus 2 is 0 here. Okay, so our number here is 1, 1, 1, 1, 1, 0, 1, 0. Okay, so 252 is, 250 is, what is 250? 1, 1, 1, 1, 1, 0, 1, 0. Okay, this is how it's working here. So let's see, let's put this on internet and see if this is correct. I hope it's correct here. So let's see binary conversion. So decimal to, so I'm going to type 192 and I'm going to convert. It says followed by, so the very first one, yep, the first one came out to be accurate here, okay? And let's put down 68. Ooh, okay, so 168, convert. And it did come out to be accurate here, 1, and convert. And okay, so the binary number is saying 1 here, but this is actually, this is what's supposed to be. Okay, and what 250 and 250 is also we calculated accurately. Okay, so this is, don't stress too much about this here, but you should know when these numbers are being used here. Okay, so okay, now our final number for 192.168.1.250. This is how the computer is going to remember that number here. So let me copy, paste, copy, paste, copy, paste, copy, paste here. Okay, so what is this here? This is nothing but a numbers here. And remember, these numbers are not going from left to right. It's going from right to left. Okay, numbers move from Numbers are from right to left. Okay, why is it going from right to left? Because what is numbers? 0 to 9. What are these numbers? These numbers are nothing but these are Arabic numbers, Arabic numbers. Okay, so if you put down in here, um, if you put down like numbers here, so it's coming up. No, you just type numerals. Okay, when you type numerals here, the numbers are coming up. But if you type like the Arabic numerals, so these are 1, 2, 3, 0 to 9 is called Arabic numerals. And since Arabic moves from left to right to left, that's why it's called. All these numbers are moving from right to left here. Okay, so okay, I'm gonna end here right on time. I'm gonna make sure all this video is uploaded and everything. And then if you guys have any questions, put it in a chat, and I will pick it up next week from here. Okay. So once this is done, I will upload the videos and all. So everybody have
Thank
a
you,
good
Zafar.
weekend. Yeah, sure.
You too,
No
Zafar.
problem.
Thank you. Have a
Yeah,
good one.
you too. Love us.